Hello, so over the course of the next few slides I'm going to talk to you a little bit about A-level chemistry. Now Altwood, the course that we do for A-level chemistry is OCR Chemistry B, which is more commonly known as Salter's Chemistry. In my opinion, it's one of the best A-level chemistry courses you can get because it has a really good mix of theoretical chemistry, practical work, and also contextual examples that allow you to understand a bit better about how A-level chemistry affects the world around us and the industries that rely on it. So in A-level chemistry, we have 10 modules or units to study over the course of the 2 years. There's 5 in year 12 and 5 in year 13. So we start with elements of life in year 12, which you can see on the top of the slide there, and we carry on through the different modules and finish with colour by design right at the end of year 13. Now in these modules we'll do all types of different theoretical chemistry, there'll be different practicals, and also each of these modules has a contextual example underpinning all the theory that we study in that particular module. At the end of the course you will have 3 papers for exams, so that A-level paper 1, which is called Fundamentals of Chemistry, paper 2, Scientific Literacy, and paper 3, which is a practical skills paper. They're all, broadly speaking, 2 hours long, slightly more, slightly less, and it will be those 3 papers that is averaged to give your overall grade for chemistry. There's also a separate aspect that you'll be awarded, which is called the A-level practical endorsement, and I'll talk more about that in one of the later slides. So you'll be familiar with your online Caboodle textbook from GCSE, and it's going to be a similar thing at A-level with chemistry as well. So you'll be able to access the core textbook for the course online using the Caboodle platform, so it's going to be very familiar to the way that you've done that for GCSE. So here's a quick example of what that online textbook looks like. All the chapters that we have in A-level chemistry textbooks start in the same way. They always start with a contextual example of the chemistry that you're about to learn about. So on the left hand side there, the slightly pinky reddy section talks about the context on which the theoretical chemistry will be introduced for this particular chapter. It then moves on to the underlying theory and the theoretical chemistry that you need to learn for the course. So I mentioned the practical endorsement earlier. So what we have now in A-level chemistry is you'll get your final grade, so A, B, C, whatever that might be, based on your average of your 3 exams, those exam papers you're sitting. But separately to that, you will be awarded something called the practical endorsement, and that will also be on your results day certificate, and it will either be listed as a pass or a fail. Now, the way that that is awarded is that over the course of the 2 years, you do lots of practical activities, and while you're doing those, I'm monitoring and assessing the development of your skills. So looking at how competently you can use the equipment, are you working in a safe and logical manner, and are you improving that over the course of the 2 years. There's quite a lot of practical activities over the 2-year course. I would say there's probably in total around 50 or more practical activities that we have that we could potentially do. So there is plenty of opportunity to make sure that you demonstrate to me the skills necessary for that practical endorsement. So as long as you make sure you're in lessons, your attendance is good, and that you act on the advice I give you, you can be very confident that you're going to pass the practical endorsement side of the course. So here's an example of one of the practical worksheets that comes from the Year 12 course. This one's from the Developing Fuels module, and this is investigating the enthalpy change of combustion. So they all have the same layout. There'll be the learning outcomes to begin with, a little bit of background, safety aspects that we need to consider before we're doing the practical, and then there'll be a method, and that will be followed by a results table and instructions about how to do your write-up for that practical activity. So here we can see the results table for this particular practical and the questions there, which will lead you through the calculations that need to be done for the write-up. and obviously I'll be there to support you at each step during this process. I think one of the big differences between GCSE and A-level sciences that students notice is the big increase in the amount of practical work. On a typical week, I would say we probably have a couple of lessons which are actually practical activities, and then the other 2 or 3 lessons will probably be theory. So it's approaching 50% of the course time dedicated to practical activities. But those practical activities will reinforce some of the theory that you've been learning about in the other lessons. So I've already spoken a little bit about the assessment aspect of the course. On the right hand side of the slide here, we can see again the names of the 3 papers that you'll sit as exams at the end of the course and their relative weightings. But also throughout the course, for each unit that you do, elements of life, developing fuels, elements from the sea, for each one of those modules, at the end of the module we'll have a unit test assessment, so an internal assessment under exam conditions, which then you will get feedback on, very similar to the PLCs that you will have encountered in Year 11. So you've got clear feedback as to the areas where you're currently doing well, and perhaps those areas that you need to look at again and develop going forwards. Chemistry can take you in a whole range of different directions at university and beyond. Chemistry is necessary for some things that you may already know about. So for example, if you were thinking about going into medicine, chemistry is a prerequisite study for that. Or if you were thinking about going into the chemical industry, obviously chemistry would be required. But there are many other careers and degrees at university where chemistry is either necessary or can be a real advantage. Chemistry graduates from university have gone on into careers such as law and finance, as well as many other areas as well. If you're interested about more detail for what sort of careers chemistry can take you into, I'd really recommend you have a look at the website for the link that you can see on the screen at the moment. So edu.rsc.org/future in chemistry, and that will give you a really wide range of different careers that chemistry can help you achieve. I hope that's helped answer some of the questions you may have had about A-level chemistry. I think one of the real strengths of A-level chemistry at Altwood is that we typically have much smaller class sizes than you'll find in colleges or other schools. And having these smaller classes really allows students to get involved in every single lesson, and it also means that I'm able to question students on a more regular basis to ensure that they fully understand what it is that they are discussing and what it is they need to know. If you do have any further questions, please don't hesitate to contact me, and I'll also be available on the Sixth Form information evening to answer questions then as well.